Welcome! Today we'll explore the limit of sine x divided by x as x approaches infinity. Let's write out what we're trying to find. To understand why this limit equals 0, let's visualize it graphically. First, let's draw our coordinate axes. The blue curve shows sine of x, which oscillates between -1 and +1. The green curve shows 1 over x, which approaches 0 as x increases. Now, let's look at sine x divided by x. This red curve shows our function sine x over x. Notice how it oscillates between the positive and -1 over x curves, getting smaller and smaller as x gets larger. Let's understand why this happens. By the Squeeze theorem, since sine x is always between -1 and 1, sine x over x must be between -1 over x and +1 over x. As x approaches infinity, both 1 over x and -1 over x approach 0. Therefore, by the Squeeze theorem, sine x over x must also approach 0. To summarize, as x gets larger, sine x continues to oscillate between -1 and 1, but dividing by x makes these oscillations get smaller and smaller, eventually approaching 0.